Good day, class! Today ay magsisimula na tayo sa AC analysis of the BJT amplifier. Ang gagamitin natin is yung R sub E model. But before we start on the R sub E model, let us first recap what you have learned in Electronics 1, the diode characteristic curve. So for the diode characteristic curve, ang ipapakita ko sa inyo ngayong illustration is the forward bias region. So para kuha natin yung mga different DC levels. Kasi we have two. We have the DC or the static resistance and we have the AC or the dynamic resistance. Yung dynamic resistance, yung pangalawa, yun ang gagamitin natin sa R sub E model. So for this one, what if ang in-apply natin na bias sa ating diode is DC? So of course, there will be a DC voltage and a DC current. Yung pares ng DC voltage and DC current na yon, it will represent your Q point or yung operating point na tinatawag natin. So as you can see here sa ating diode characteristic curve, for example, nandito yung Q point natin. Kapag pinoject natin siya pababa, ay may corresponding V sub D. Pag pinoject natin pakaliwa, ay merong corresponding I sub D. So pares yan ng voltahe at kuryente sa ating diode. But paano natin makakalculate yung resistance at that certain point? So madali lang yun, no? Ang resistance natin can be calculated using Ohm's law. Alright? We have R sub D, C. This is the DC resistance, alright? Or the DC resistance of the diode. That is just equal to V sub D divided by I sub D. Alright. Fixed yung ating V sub D, fixed din yung ating I sub D, therefore fixed din yung ating R sub DC. So hindi siya nagbabago. This is called the static or the DC resistance. But what if ang in-apply natin sa diode is AC? So what will happen to the diode voltage and the diode current? So for example, meron tayong sine wave na in-apply sa ating diode. And we will project that onto the diode characteristic curve. As you can see here, nagbabago yung kuryente natin. So it has a change. Hindi kagaya nung sa DC resistance kanina, fixed lang siya. No? So it will vary between these 2 points. Okay? So habang nagbabago yung kuryente natin, may corresponding na pagbabago rin sa ating voltage. Alright? So yan yung magiging effect sa voltage and sa current ng ating diode kapag ang in-apply natin ay AC. So syempre, nagbabago-bago yung kuryente at nagbabago-bago rin yung ating voltahe. No? Ano ang magiging resistance niya? Nagbabago rin. So that's why this is called AC resistance. So how do we determine the AC resistance? So it's easy. No? So dito muna tayo. Kung susukatin natin to, this is called delta I sub D or the change in the diode current. So delta means change, diba? Or delta can also be represented as a derivative. So it's the derivative of I sub D, the change in diode current. But what about this one? So if we're going to represent this one, this is called delta VD or the change in the diode voltage. So how do we calculate the AC resistance from those quantities? No? So we have R, A, C. This is your AC resistance. As you notice, small caps yung ginamit ko, na small caps because it represents an AC quantity. So this is equal to the derivative of the diode voltage with respect to the derivative of the diode current. No? So habang nagbabago yung voltahe, no, nagbabago rin yung ating kuryente. Next is, let us recap Shockley's equation for the diode. So we have I sub D or the diode current is equal to the leakage current or the reverse saturation current multiplied by E. So ito yung natural logarithm, no? Raised to V sub D over N VT minus 1. In our previous video lecture, tinanggal ko na yung N kasi N is just an ideality factor. Usually, ang value niya ay 1 or 2. So, it dictates the shape of the curve. So, it's okay to approximate N dito to be 1. No? Kaya pa pwede nating tanggalin siya. So magiging VD over VT na lang yung exponent natin. Alright, so from this equation kasi, makukuha natin yung RAC, which will be utilized for the R sub E model. So paano gagawin natin dito? Kukunin natin yung derivative of ID with respect to the derivative of VD. And then mamaya babalik ta rin natin siya para makuha yung RAC. So for this one, we have derivative of ID with respect to ano siya? With respect to the derivative of VD. So change in diode current with respect to the change in diode voltage. Kasi mamaya babalik ta rin natin yan, as I've said, para makuha yung RAC. Equals. Kinuha natin yung derivative ng left-hand side ng ating equation, therefore, dapat kunin din natin yung derivative ng ating right-hand side. So, if we will just distribute I sub s, no? So, magkakaroon tayo ng derivative of I sub s, e raised to VD over VT with respect to derivative of VD, alright, minus derivative of I sub s with respect to derivative of VD or the diode voltage. Next, no, i-determine natin ano ba yung mga constants dito. No? Yung I sub s is a constant value. No? This value depends on the type of diode na gagamitin natin. Alright? V sub D is a variable, so it changes. V sub T is the thermal voltage, so can you still remember Boltzmann's constant, yung charge ng one electron, so on and so forth, no? So kapag merong changes in temperature, nagkakaroon tayo ng tinatawag na thermal voltage. Alright, so that's represented by V sub T. Next, I sub S again is constant. Ano kayang derivative ng I sub S? Di ba ang derivative ng constant ay 0? So we can eliminate this one. Alright? So ang matitira sa right-hand side ng ating equation is yung constant, di ba? Matik yan. Ilabas natin sa kaliwa. I sub S times the derivative of E raised to VD over VT with respect to derivative of VB. So this is just a classic case of differential calculus, no? So napakadali lang nito. So dito tayo mag-focus muna. Ano ang derivative ng e raised to u? Di ba alam natin derivative of e raised to u is equal to e raised to u du. In this case, ano yung nagsisilbing u natin? So ang u natin dito is vd over Vt. Alright? So, what is du? Or the derivative of u? Remember, di ba ang ating V sub D is a variable and V sub T is a constant. So, later on, kukunin natin yung value ng V sub T for the common temperature of electronic circuits in an enclosed system. Right? This is taken with respect to the change in V D. Alright. So this is derivative of VD with respect to derivative of VD times 1 over VT. So ito, kinuha lang natin yung derivative niyan. Ito yan. We can cancel this out kasi 1 naman yan, di ba? Derivative of VD with respect to derivative of VD is equal to 1. So matitira is 1 over VT. So this is your du. Kailangan natin makumpleto, no, yung ating derivative. So this is equal to I sub S times, so yung derivative nito, this is e raised to u, yan yon. Derivative of e raised to u is e raised to u times du. So we have e raised to u, ano yung du natin? 1 over Vt. So we have, lagay na lang natin over Vt dito. Next, we can now simplify this term. Di ba ito yung original Shockley's equation natin? So, dinistribute ko lang dito yung I sub S. No? So, ito, may nakikita tayong kamukha dito sa original Shockley's equation, di ba? So, we can express this one in terms of the original Shockley's equation. So ito yung kamukha nyo, yung first term sa right hand side ng ating equation. So we have now ID plus IS is equal to IS times E raised to VD over VT. Ayun yun. So pwede nating ipalit to dito kasi pareho lang naman yun, di ba? So we have, medyo hatiin natin dito. This is equal to, instead of using this term, we will use ID plus IS kasi equal siya doon. Okay? So we have ID plus IS. So itong term na to, napalitan ng ID plus IS divided by V sub t. So later on, kukunin natin yung value ng V sub t na yan. Okay. But ano bang difference ng diode, forward diode current tsaka ng reverse saturation current? Hindi ba't ang reverse saturation current is sobrang liit? No? So in the range of nano or microamperes yan or maybe even picoamperes. Ano ang level ng I sub D? Naka-milliamperes yan. So higit na mas malaki yung I sub D sa ating I sub S. That is why we can approximate this one to be approximately equal to I sub D over VT. So parang nag-add ka ng let's say 1 million plus 1,000. Diba? Or 1 million plus 10,000. Yung butal na yon, pwede na nating approximate dun sa mas malaking value. Dahil mas malaking I sub D, pwede na nating i-omit yung I sub S dahil sobrang liit niya. So magiging I sub D over V sub T na siya. Alright. So now we have derived the derivative of the diode current based on Shockley's equation with respect to the derivative of the diode voltage. Ito yon. Di ba kanina meron tayong Shockley's equation, kinuha natin derivative with respect to derivative of VD, nagkaroon tayo ng ID over VT. Now, ito yung sabi ko sa inyo kanina, no, kailangan i-derive muna natin yung V sub T or yung thermal voltage na tinatawag. Recall, in electronics 1, ang thermal voltage is equal to K times T over Q. Wherein K is Boltzmann's constant, 1.38 times 10 raised to negative 23 joules per Kelvin. And T is the temperature in kelvins again. And Q is the charge of one electron. So that's 1.602 times 10 raised to negative 19 coulombs. So let us just write that down. Boltzmann's constant is 1.38 times 10 raised to negative 23 joules per Kelvin. Right? Ano kayang gagamitin nating temperature? Ang normal temperature ng mga electronic device or the common temperature of electronic devices in an enclosed system is 27 degrees Celsius. So we can write it here, 27 degrees Celsius. But as you can see, kelvins yung ginagamit natin na unit dito. So in order for us to convert from Celsius to Kelvin, mag-add tayo ng plus 273.15 para siya maging kelvins. Alright? Divided by 1.602 times 10 raised to negative 19 coulombs. So this is the charge of one electron. So bakit ito yung ginamit natin? So ano bang matitira dito na unit? No? Yung ating kelvins, makakancel na yan. So ang matitira is joules per coulomb. Hindi ba't ang joules per coulomb is also equal to volts? Ano ba yung hinahanap natin? Thermal voltage. Hindi ba ang unit nga ng voltage is volts? Okay, so dapat matira dyan is yung joules per coulomb. And calculating for the thermal voltage, kapag ang temperature natin ay 27 degrees Celsius, magkakaroon tayo ng sagot na 0.0258 volt. But we can convert this into millivolts, no, para mas simple yung ating value. So to convert this into millivolts, kinakailangan i-move natin ng 3 decimal places to the right. So we have 1, 2, and 3. So the thermal voltage is equal to 25.86 millivolts. But this can be approximated into a whole value ng millivolts. So this is equal to 26 millivolts. So ibig sabihin yan yung voltage na na-develop sa ating diode kapag meron tayong certain temperature na 27 degrees Celsius. So that's the thermal voltage. We have calculated the thermal voltage to be equal to 26 millivolts. Pwede na nating i-substitute dun sa ating the derivative ng ating Shockley's equation. So we have derivative of I sub D with respect to the derivative of V sub D or the diode voltage. That is equal to I sub D, the diode current, divided by the thermal voltage of 26 millivolts. Alright, so paano natin makukuha yung AC resistance or dynamic resistance? Yun nga yung objective natin, di ba? Makuha yung AC resistance ng PN junction diode kasi yun ang gagamitin natin sa R sub E model ng mga transistors. Remember kanina, we have RAC that is equal to the derivative or the change in V sub D with respect to the change in I sub D or also the derivative of I sub D. So, kung mapapansin nyo dito, no, inverse lang itong dalawang term na nakikita natin. So, ang gagawin natin, babalik ta rin natin to, if-flip natin ganyan. So, we have the derivative of VD with respect to the derivative of ID. Binaliktad natin yung left-hand side, therefore, babalik ta rin din natin yung ating right-hand side. So, we have 26 millivolts divided by I sub D. E di ba't pareho lang yan? Don't mind the subscripts, no? Pareho lang yan, no? Because we're getting the AC resistance, no? So this is equal to R AC. Alright? So that we can summarize it to be RAC equals 26 millivolts over I sub D. So this is the AC or the dynamic resistance ng ating PN junction diode kapag ang ina-apply natin ay isang AC na signal. Iba ang resistance niya kapag DC yung in-apply natin. Okay? Gagamitin natin to sa R sub E model because as we discussed before, ang BJTs, ang common base, common emitter, no, ginagamit natin siya bilang isang amplifier. So as amplifiers, pinapower natin siya or binabias natin ng DC, yung circuit natin, and then nagpapasok tayo ng AC for it to be amplified pagdating naman sa ating output. So merong involved na AC signal yung ating BJT amplifier. So onting pasakalya muna tayo, no, bago tayo dumating sa R sub E model natin. Let us take a look first at the AC block diagram. Itong block diagram na to, it represents, no, any BJT amplifier, no. Ang ating input side is represented by R sub I, which is the input resistance or input impedance. And R sub O, yan yung ating output resistance or output impedance. So itong block na to, yung nasa loob niya, it may be a fixed bias circuit, it may be a common base circuit, it may be a voltage divider, it may be a DC bias with voltage feedback na circuit. So any BJT amplifier, no, ay pwedeng nasa loob ng ating block symbol or ng ating block diagram. This is just used to illustrate yung mga AC components or AC parameters ng ating BJT amplifier. Alright. What if nag-apply tayo ng input signal sa input side ng ating amplifier? No? So let's say meron tayo ditong maliit na AC signal. Ano daw yung magiging corresponding output natin for that one? Diba, for example, this is a common base. Diba sa common base, in phase ang input signal sa output signal, pero it is amplified. So we're expecting here sa output na mas malaki yung ating signal and in phase with the input. Alright. So we call that input signal V sub I. As you notice, yung ating subscript ay small caps because that is an AC value or AC parameter. Nag-apply tayo ng input signal dito sa input port. So this is called a port, no? Input port ng ating circuit. In-apply natin do sa input resistance or input impedance. Magkakaroon tayo ng ano? Siyempre, magkakaroon tayo ng kuryente. Resistance, in-apply mo ng voltahe, magkakaroon siya ng kuryente if it is a closed circuit. So we have I sub I. Ang convention natin with the AC model is papasok. Alright, so this is I sub I. That's the input AC current. that is being supplied by the input AC signal with a value of V sub I. Alright. That will translate onto the output. No? So may gagawin dyan sa signal na yan, yung ating amplifier. So of course, i-amplify niya. No? Sa output natin, it is represented by V sub O or the output AC voltage. Ito yon, yung malaking yan. That is your V sub O. And then, meron tayong convention na ginagamit for the output current. That is I sub O, papasok. So as you noticed, yung dalawang kuryente natin, yung input tsaka output, papasok siya pareho. Yung input tsaka yung output current na yan, later on when we go to the different configurations, magkakaroon na tayo ng specific subscript for that. So yung I sub I natin, posibleng maging I sub E. Yung I sub O natin, pwede maging I sub C. No? So depende sa configuration na ina-analyze natin or ginagamit natin. And now we proceed to the R sub E model. Ito tayo, na. So gagamitin natin ngayon ay isang PNP na BJT. Ang i-analyze natin ngayon using the R sub E model is yung common base configuration muna. And then sa mga succeeding lectures natin, i-analyze natin yung common emitter and yung common collector natin. Alright. For the common base, diba, ang input side natin ay base emitter at ang output side natin is the base and collector junction. So, para maging amplifier siya, recall, no? Ang ating base emitter junction should be forward biased and the base collector junction should be reverse biased. So kapag naka-forward bias yung ating base and emitter junction, no, maglagay lang tayo dito ng plus and minus polarities to indicate na siya ay naka-forward bias, no? Di ba magkakaroon tayo ng resistance, no? And it's determined by the Q point if ang input natin is DC. But what if ang input natin ay AC? Diba ang purpose nga nitong amplifier is makapag-amplify ng input AC signal. So kapag nag-apply tayo ng input AC signal sa PN junction, ito yun, no? P and N junction, diba parang diode din yan? Alright? So anong resistance yung nag-o-occur or lumilitaw, kumbaga, dun sa ating PN junction kapag nag-a-apply tayo ng AC signal? Hindi ba't yung RAC? Therefore, the input side should be represented by the AC resistance. Di ba kanina yung AC resistance, kinuha natin from Shockley's equation. So we have RAC is equal to 26 millivolts divided by ID. Pero hindi na siya diode ngayon, di ba? It's a transistor. So bago na yung tawag natin dun sa ating RAC. So we call that R sub E na ngayon. Yung kaninang RAC, which is the dynamic or the AC resistance ng diode, is a term applicable kung diode. Pero kung transistor naman tayo, no, sa BJT, ang gagamitin natin is R sub E. So this is equal to 26 millivolts over I sub D. Ito naman, ang R sub E natin, this is equal to 26 millivolts, hindi na I sub D ngayon. Okay? Ano ba yung input current natin dito? Di ba I sub E? So, instead of using I sub D, we use I sub E or the DC emitter current. So, interpret natin to, no? Ang AC emitter resistance, ito yon. Yung R sub E is called the AC emitter resistance, is dependent on the DC emitter current. Uulitin ko lang. Ang AC emitter resistance ay nakadepende sa DC emitter current. Because remember, dun sa ating characteristic curve, diba, meron tayong gitna nung sine wave natin. So dun maglalaro yung ating AC signal, yung level nung emitter current na yon. Alright? So ito yung magiging equation na gagamitin natin to represent the input side of our R sub E model. Ang objective natin, yung input side is represented by the R sub E model. So, depende ito sa configuration. Sa common base, since meron tayong PN junction, it can be represented as a single resistor na R sub E. Dito sa input side ng ating R sub E model, na meron tayong representation. No, again, ang ating model is just an approximation, no, approximation of the AC behavior ng ating circuit. So this is just a representation of the input side. Input natin, we can represent that by a single resistance na R sub E. So this is for common base, ha. Kasi pagdating natin sa common emitter, magbabago na yung ating input resistance. Alright, so sulat na natin. This is for common base. As you can see here, ang input terminal natin is the emitter. We have the common terminal or the common layer, which is the base. And as you can see, small caps yung ginamit ko because this is an AC model. Now, we're in sa DC analysis natin, capital yung ginagamit natin for emitter, the base, and the collector. Okay, so good na tayo sa ating input side. But what about for the output side? Sa R sub E model, ang output side natin is represented by this one. Ano kaya itong symbol na to? Ano yung merong diamond shape? So, recall natin sa circuits 1 or sa electronics 1 natin, ano ba yung schematic symbol na merong diamond shape? Hindi ba ginagamit natin yan for a dependent source? In this case, sa R sub E model, i-represent natin yung output side by a dependent current source. Okay? Ano ba yung output current ng common base? Hindi ba't I sub C? Therefore, yung output side natin should be represented in terms of I sub C. So, i-drawing natin siya dito. Ito yung ating common, yung base. Magkakaroon tayo dito ngayon ng diamond shape. And this is your collector. But the question is, ano ang direksyon ng ating dependent current source? Yung arrow ba natin dapat ay pataas or dapat pababa? Ang ginagamit natin ngayon ay PNP. Alright? So, ibig sabihin, papasok yung I sub E and yung dalawang kuryente natin, I sub B and I sub C, ay palabas. No need to write I sub C dito sa ating R sub E model. Ang concern lang natin is yung I sub E tsaka yung I sub C. So, papalabas yung I sub C. Ito yung I sub C natin. Kaya pataas yung direksyon ng ating dependent current source. Anong isusulat natin sa tabi niya? So, kinakailangan isulat natin yung variable kung saan nakadepende si I sub C. Di ba si I sub C ay nakadepende sa input current I sub E? Alright, so this is your I sub E. Si I sub C nakadepende kay I sub E. Anong relationship ng dalawa? Hindi ba't alpha? Alpha is equal to I sub C over I sub E. Again, small caps yung ginamit ko because these are AC parameters. So we can write down here I sub C is equal to alpha times IE. Ito yung I sub C mo, ito yung dependent current source, it can be represented by alpha times I sub E. Wherein ang normal value ng alpha is approximately equal to 1. But in reality, di ba, nasa 0.998 yan. No? So, magiging less than 1 yung ating alpha. So, ang pinakamalaki is si I sub E. Ang susunod sa kanya is I sub C. No? Dun sa mga kuryente natin. So, this is the common base R sub E model para sa PNP. Pero if we have an NPN, syempre, magbabaliktad yung direksyon ng ating dependent current source. So, let us now proceed to an example. So, maglalagay tayo ng external resistances. So, parang DC analysis na sinold natin, no? May external resistor, may external supplies. This is our common base example circuit. Katulad ito nung unang example ng common base natin for the DC analysis discussion. We have a PNP BJT. We have external resistors. We have R sub E, which is the external resistor connected to the emitter terminal. We have R sub C, which is the external resistor connected to the collector. and we have two power supplies. We have V sub EE, which is 2 volts, and V sub CC or VCC of 8 volts. Alright? So they are oriented in such a manner na kinakailangan ma-forward bias yung base emitter terminal at ma-reverse bias ang base collector terminal natin. So we have, this is P and P, no? So P type should be positive, N type should be negative. So okay. So we have P and N. P type should be negative and N type should be positive. So our transistor is properly biased para maging isang amplifier. Alright. These are the parameters. We have alpha of 0.98. Ito yung sinasabi ko sa inyo, no? Ng actual value talaga ng alpha is less than 1. But this can be approximated sa 1. Kasi almost equal naman ang I sub C tsaka ang I sub E natin. The output resistance is equal to 1 meg ohm. Usually, itong output resistance natin, hindi na natin inilalagay sa ating output side for the R sub E model dahil sa sobrang taas niya. This is 1 million ohms. So, essentially, that can be considered as an open circuit. So, hindi na natin kinakailangang ilagay yung output resistance R sub O natin. But if we should write it down or if we should draw it, ay nakaparallel lang siya dun sa ating dependent current source. Alright. We have input and output coupling capacitors, 10 microfarads. By the way, no, itong value ng ating mga capacitors, whether it is coupling or bypass capacitor, hindi basta-basta hinuhulaan yan. Sinusolve po natin yan based on the driven resistance. As we go on with our discussion, malalaman natin paano ba sinusolve yung values ng ating mga capacitors. So darating din tayo sa lecture na yan. The first step here is to do a DC analysis. Kasi kinakailangan natin masolve si I sub E to get R sub E. Remember, ang R sub E is equal to 26 millivolts divided by I sub E. So we need to get the DC emitter current. So yan yung first step natin. So to get the AC, the DC emitter current, puputuli muna natin yung collector side natin. Sa DC analysis, lahat ng capacitors are considered to be open. So pwede nating i-omit na yung dalawang capacitors na yon. And puputulin natin pansamantala yung collector terminal because it's not part of the input side. So we have input side. Yung base emitter junction lang ang kabilang dyan. So ilagay natin, no? So this is the emitter and this is the base. Ihang natin pansamantala yung ating collector. So we have R sub E of 1 kilo ohm. Right? And then we have an external power supply VEE of 2 volts. So this is your input side. So to get the parameters of the input side, kailangan natin isulat yung induced polarity. So we have plus, minus, plus, minus. Since naka-forward bias yung base emitter junction natin, magkakaroon tayo dito ng VBE, which is equal to 0.7 volt. Okay? Next, after writing down the induced polarities, lalagay natin yung kuryente. So, anong kuryente yung dumadaan kay R sub E? Hindi ba't I sub E? Kasi konektado siya dun sa emitter terminal natin. So, anong direksyon ng I sub E natin? So, susundan lang nating arrow. That is your I sub E. Alright? So, let's do the KVL clockwise again. Let's write down the KVL equation. Magsimula tayo dito sa minus 2 volts. So, minus 2 volts plus IE times RE. IE is unknown but RE is unknown. Pwede na nating irekta. IE times RE. So, rektang isulat na natin. Plus VBE of 0.7 volt equals 0 volt. Yan yung KVL natin for the input side. Alright? We can get the value of I sub E. So, this is equal to 2 volts minus 0.7 volt. I sub E is equal to 1.5 volts divided by 1K. So again, nagde-divide tayo ng volts sa kilo ohms. Ang magiging sagot natin ay naka milliamperes. So 1.3 over 1 is 1.3 milliamperes. So ang I sub E natin is equal to 1.3 milliamperes. Gagamitin natin yan to solve for R sub E. Now we can get the value of R sub E. The equation for the R sub E, or the AC emitter resistance, is equal to 26 millivolts divided by I sub E. Isa-substitute lang natin yung nakuha nating DC emitter current kanina. We have 26 millivolts divided by 1.3 milliamperes. So makakancel dito yung 2 milli. Volts over amperes is ohms. This is now equal to 20 ohms. So maliit lang talaga ang value ng ating R sub E. Now that we have determined the value of R sub E, or yung tinatawag na AC emitter resistance, pwede nating i-draw yung ating R sub E model for the common base. So this is our input side. It's represented by R sub E. The drawing natin, this is just a representation ng ating input side, and the output side is represented by a dependent current source. So pataas yung direction ng ating arrow, it's because it's a PNP. No? Palabas dapat yung I sub C natin. No? Sinusundan niya lang yung direction ng ating I sub C. And then that's alpha times I sub E. So this is your R sub E model para sa ating common base. No? This is your emitter, this is your base, ito yung common, and this is your collector. Again, naka small caps because we have an AC model. Now, this is just the AC model or the R sub E model nung BJT. Pero meron tayong mga external components. Paano natin i-integrate yung mga external components na yon papunta sa ating AC model, sa ating R sub E model? Okay. Ang first step natin dito is to zero out all DC components. Ano ba yung mga DC components natin? We have VEE or V sub EE, and we have VCC or V sub CC. Those are DC components. Easy-zero daw natin siya. So, paano natin easy-zero yan? So, theoretically, isi-short out natin yung mga DC components natin. Nung sinort out natin yung DC components natin, it's as if na parang wire na lang sila na nakakonekta sa ground. So, dito muna tayo sa R sub E. Yung R sub E should be connected sa emitter terminal at sa ground. Mawawala na yung ating 2 volts dito because DC yan eh. No, lahat ng DC isi-zero natin sa AC. So, this is just a theoretical step. Hindi talaga tayo naglalagay ng wire sa pagitan ng VEE. Okay, this is just a method, no, para makuha natin yung AC model natin. Dito naman sa R sub C, ganun din. Ang R sub C natin is connected between the collector and the ground kasi nga meron na tayong short circuit sa pagitan ng ating VCC. Okay, so i-translate natin siya ngayon dito sa ating R sub E model. So R sub E, saan nakakonekta yung isang terminal niya? Sa emitter. Ito yung emitter, saan nakakonect yung isang terminal niya? Sa ground. So, yung base natin, konektado yan direkta sa ground, di ba? So, ito, nasa baba, this is your ground. So, ang R sub E natin will be connected in this manner. So, we have R sub E of 1K. Di ba kanina dun sa ating original circuit, meron tayong DC, power supply na nandun. But since AC na ang usapan, lahat ng DC naka-zero. So that's why ganito na ang itsura ng ating R sub E. The same with R sub C. So nasa collector and ground yung ating R sub C of 5 kilo ohms. Ano naman kaya mangyari doon sa mga capacitors natin under AC conditions? Remember, meron tayong tinatawag na X sub C or the capacitive reactance. Ito yung resistance or impedance ng mga capacitor. Now, this is dependent on the value of the frequency. So, ang equation natin dyan, pinag-aralan naman natin to before, no? 1 over 2 pi FC. Ang C is capacitance in farad, so that is constant. Frequency, pwede natin baguhin, so variable yan. Kapag tumaas ang frequency, what will happen to X sub C? Bababa siya. So kapag mataas ang frequency natin, ang capacitors are assumed to be short circuit. Okay? So kapag DC, it's open to be open circuit. Kapag AC, it's assumed to be short circuit. So parang wire na lang yung mga capacitor natin. So ito yung capacitor natin, tsaka ito. Dahil under AC, we're assuming na mataas yung frequency. Alright? Next, so we're going to apply the input signal between the emitter and the base terminal. We have plus and minus V sub I. So dito pumapasok yung kuryente and then dito lumalabas. Right. So ano ulit yung kuryente na napoproduce ng V sub I? Di ba't I sub I? So ito yung ating I sub I. Alright. The question is I sub I also equal to I sub E? To be exact, no, or to be precise, hindi sila equal talaga. But we can approximate I sub I to be equal to I sub E. Bakit? Dahil sa sobrang liit ng value ng ating 20 ohms compared dito sa ating 1,000 ohms. So majority ng kuryente ay napupunta kay 20 ohms dahil maliit yung resistance. Diba? Current takes the path of least resistance. So onti lang yung napupunta dito, mas marami yung napupunta dito ngayon. That's why we can approximate I sub I to be I sub E. Next, how about the output? Dahil meron tayong input voltage, no? Meron tayong input signal, i-amplify yan ng common base at magkakaroon tayo ngayon ng output signal voltage represented by VO. Hindi ba't ang convention natin sa AC model, yung mga kuryente ay papasok? Papasok yung I sub I, what about for I sub O or yung output current natin? So papasok din. Wala naman tayong external load dito. So ang kuryente natin manggagaling dito kay RC. So tatanggalin ko lang tong line na to para hindi kayo malito, no? Papasok yung ating I-O. Alright? So that is the complete R sub E model ng common base configuration. Next is let us calculate for the input impedance Z sub I. Ang Z sub I or the input impedance is measured before the capacitor. Papasok sa ating circuit. And di ba't yung capacitor natin under AC condition naman ay shorted, so wala tayong problema dyan. So we will write down an arrow here, no? That will represent our Z sub I or the input impedance. So parang tinitignan natin sa part na yan, ano ba yung mga nakikita natin na resistance? Nakikita natin yung R sub E and yung R sub E. Actually parehong R sub E siya, yung isa ay external resistance, yung isa ay AC emitter resistance. Anong connection sa pagitan nitong dalawang resistances na to? Hindi ba't nakaparallel sila? Alright? So we can calculate Z sub I or the input impedance to be R sub E parallel with R sub E. Alright. So Z sub I is equal to 1 kilo ohm times 20 ohms divided by 1 kilo ohm plus 20 ohms. So you have to express this in the same units, no? So this is 1,000 ohms, 1,000 ohms, 20 ohms, 20 ohms. Z sub I or the input impedance is equal to 19.61 ohms. So halimbawa wala kayong calculator tapos gusto nyong malaman yung approximate value ng dalawang resistances na nakaparallel. So halimbawa to 1K or 1,000 nakaparallel siya kay 20 ohms. Ang magiging total resistance natin kapag nakaparallel ay mababa. So bababa yung total resistance natin. So that is lower than 20 ohms. So pag tinanong sa inyo 1K parallel with 20 ohms, ang pwede natin isagot is lower than 20 ohms or approximately 20 ohms. Alright? So, this is solved to be 19.61 ohms. Yan ang property ng mga common base. Mababa ang input impedance, pero ang output impedance natin ay mataas. So, later on, no, masosolve natin yung output impedance pagdating natin sa part na yon. Now, why is input impedance very important? Una, yung input impedance na yan, no, it determines how much of the input voltage or input signal is being fed into the circuit. Ilan ba yung pumapasok dun sa ating circuit? Kasi merong internal resistance yung mga sources. Nagkakaroon tayo ng voltage divider. Alright? Pangalawa, ang input impedance natin ay ginagamit natin kung meron tayong multi-stage na connection or yung tinatawag na cascaded. No? Yung input impedance ng, for example, ng stage 2 is the load of the first stage. So anyway, darating din tayo sa part niyan. No? I'm just trying to establish the importance of Z sub I or the input impedance. The output impedance naman is taken after the output coupling capacitor. Yung output coupling capacitor natin shorted na, diba? So parang wire na lang siya. So hindi na tayo magkakaroon ng problema dyan dahil dito natin siya susukatin. Ano bang nakikita natin sa part na yan na resistance? Anong resistance lang ba yung nakikita natin dyan? Hindi ba't yung 5K? Therefore, the output impedance is equal to 5K. Eh di ba meron tayong given na 1 meg ohm na output resistance? Supposed to be nandito siya. Yung 1 meg na yon. Pero since sobrang taas ng value niya, yun nga yung property ng ng common base, no? Yung output resistance natin, yung output impedance mataas. Okay? So parang considered to be open circuit na lang siya, yung R sub O natin, dahil 1 million ohms yun i-parallel mo siya sa 5K, anong magiging total? No? Ang magiging total mo pa rin is around 5K pa rin yan. So walang halos effect yung ating R sub O dito sa ating output impedance. Next is we'll solve for the voltage gain. Ang voltage gain is represented by A sub V. Alright? Yung voltage gain or any other gain is equal to the output quantity divided by the input quantity. So kapag voltage gain ang usapan, that's the output voltage divided by the input voltage. So this is equal to V out or VO divided by VI or V sub I. Both are AC parameters. Let us now identify V sub O muna. So V sub O or the output voltage, hindi ba't yan yung voltage across the 5 kilo ohm resistor? No? So, ano yung kuryenteng dumadaan kay 5K? Hindi ba't yung IO? Yung output current natin? So, since lumalabas yung kuryente sa positive terminal ng ating VO, ang magiging equation natin for the output voltage is negative. So, I times R. Alright? We have IO times RC. IR equals V. So, yan yung components ng ating output voltage. But, how do we relate I out and IC? Hindi ba't si IC dumadaan din yan kay RC? No? Si I out, lumalabas doon. Si IC pumapasok doon. The question is, are they equal? Yes, they are equal, but salungat yung kanilang direction. So, sa mga kuryente na same lang yung dinadaanan, equal sila, but kung salungat ang direction nila, anong relationship nila? So, I out or the output current is equal to IC dapat, but since salungat sila, maglalagay tayo ng negative doon. Okay? So, we can now replace I out by I sub C. This is equal to negative, ano ulit yung I out natin? Negative I sub C. Remember, this is small caps, hindi lang siya obvious, no? Kasi mukhang capital yung C natin, no? This is negative I C. Yung I out natin, napalitan natin ng negative IC. Right. And then, times R C. Therefore, the output voltage is equal to IC times RC. Next is we're going to determine the input voltage V sub I. So let's focus here. Yung V sub I natin, yan yung input signal na gusto nating i-amplify. No? So that's the input AC signal. That is applied across R sub E, yung external resistor natin, and also across the AC emitter resistance. So ang voltahe natin dito is VI. Ang voltahe natin dito is also VI. So we have here plus and minus VI. ano yung components ng input voltage natin? We can use this one, this part over here. So the input voltage is equal to I times R. So ganun lang kasimple. I sub E times R sub E. So that is the input voltage. The AC emitter current and the AC emitter resistance. Now, we can substitute it dito sa ating voltage gain equation. Divided by, kokopyahin lang natin yon, I sub E and R sub E. Okay, so let's just erase this one. What is the relationship between IC and IE? So IC over IE, di ba that is also equal to alpha? So we can change IC over IE here. Magiging alpha na siya ngayon. So the voltage gain ng common base is equal to alpha times R sub C over R sub E. But take note, this is just the no load voltage gain. Ibig sabihin, wala pa tayong external load na nakakonect sa ating output coupling capacitor. So this is the no load voltage gain. Substituting the values for alpha and resistances, ang makukuha nating voltage gain ay 245. Ang gain is unitless. Alright? So kapag nag-multiply tayo ng value dyan, ang magiging product niya is kung ano yung i-multiply natin. So for example, ang input voltage natin is 1 millivolt. What is the output voltage? Babalik lang tayo dito sa equation na yan. Ang hinahanap natin ay output voltage, no? So we have V out is equal to the voltage gain times V in. So ito yung ating voltage gain. We have 245. Unitless siya. For example, ang input natin ay 1 millivolt RMS. So I hope you remember yung RMS value natin, no? From Electronics 1. So therefore, this is equal to 245 millivolts. So nagpasok tayo ng 1 millivolt. Dahil may voltage gain ka ng 245, ang output mo nag-amplify. Naging 245 millivolts na siya ngayon. Last, let us solve for the current gain. Ang current gain is defined by output current over input current. So, output AC current divided by the input AC current. Ano ba yung output AC current natin? Yan ba equal sa IC? Yes, but sa lungat sila ng direksyon, kaya I out is equal to negative IC. Alright. Ano ba yung input current natin? Is it equal to I sub E? Technically, hindi. Kasi may napupuntang kuryente dito. So, kapag pumasok yung I sub I doon, may hiwalay sa pagitan ni 1K at ni 20 ohms o nung dalawang RE natin. But since maliit lang yung kuryenteng dumadaloy dito, we can approximate the input AC current to be equal to the AC emitter current. So we can assume I sub I is also equal to I sub E. Again, small caps because AC parameter sila. Therefore, the current gain is equal to negative alpha. Negative 0.98. Dahil ang I sub E divided by I sub E is equal to alpha. So bakit negative? Ibig sabihin ba nag-decrease? Yes, nag-decrease yung output natin kasi less than 1 yung ating gain. If the gain is more than 1, ibig sabihin ang output mas malaki sa input. If the gain is less than 1, ibig sabihin yung output mas maliit sa input. But does the negative symbol there indicate na mas mababa ba yung output? Hindi. It just means meron tayong out of phase na kuryente. No? Sa common base, ang input voltage is in phase with the output voltage. So pantay yan. Ito yung ating input voltage, maliit. Ito yung ating output voltage. So pantay sila in phase. Pero ang kuryente natin, no, is out of phase by 180 degrees. So this is our input current, no? This is our output current. So mas maliit ng onte dahil yung gain natin is less than 1, no? But out of phase by 180 degrees. So the input current is out of phase by 180 degrees compared with the output current. Yan ay true for the common base only. I hope you understood what we discussed today. If you have any questions, just post it in our group chat and I'll try to answer it right away. So that would be all, and thank you. Have a nice day.